own taste what kind of display unit they want to use. There is no licensing, there is no password or something to key in. It's for all the application the same app. So on here, the right measurement unit, I'm considering this as the movable machine. So I'm doing the correction on the right machine only in vertical direction and the stresses of the machine by twisting and rotating the shaft and measure them independent with a kind of offset bracket.
Yeah. Thank you, Sven, and that's all our questions. I think you have 2 more demonstrations, right?
I can, if you allow me quickly, just a few minutes, if you like to have it.
Yeah, of course, please. Halo, selamat siang pada Bapak Ibu peserta webinar Tiara Vibrasindo Pratama. Apa kabar semuanya? Semoga kita semua dalam keadaan sehat dan semangat selalu. Terima kasih sudah bergabung di acara webinar kami hari ini. Untuk webinar hari ini kita akan membawakan topik mengenai precision laser shaft alignment. Nah, bersama kami telah hadir Mr. Sven Fleischer dari 𝐒𝐲𝐢𝐬𝐜𝐡𝐞𝐫. Beliau merupakan area sales manager 𝐒𝐲𝐢𝐬𝐜𝐡𝐞𝐫. Hi Sven, good afternoon.
Excuse me. Good afternoon, Mr. Rojegi. Good afternoon, PT Tiara and everybody who is joining.
Yeah, thank you for joining us today for our webinar.
Thank you so much for having me.
Yeah, before we start with you, I will present a brief of introduction regarding to our topic today. It will take only around 5 minutes. Please allow me. Oke, terima kasih sekali lagi Bapak Ibu atas kehadirannya. Dan untuk webinar kali ini kita akan berdiskusi mengenai precision laser shaft alignment, di mana sebagai pengantar saya akan menunjukkan satu materi ya mengenai life cycle strategi. Saya akan share. Oke. Nah, bicara mengenai alignment atau Bapak Ibu sering mengenalnya sebagai salah satu failure cause, yaitu maupun shaft alignment atau coupling alignment ataupun misalignment pada komponen mesin lainnya. Nah, di sini saya akan menunjukkan kenapa kita perlu mengelola terkait dengan failure cause misalignment ya. Nah, ini ada saya tampilkan salah satu contoh pada hot well pump, di mana pada large vertical pump kita menemukan adanya failure cause, yaitu berupa shaft alignment yang memiliki failure mode berupa bearing worn out dan efeknya berupa unit derating. Nah, kita tahu setiap critical asset memiliki failure mode, failure effect maupun failure cost yang bermacam-macam. Nah, itu semua perlu kita kelola. Kenapa? Mungkin kita sudah tahu semua jawabannya. Kalau salah satu dari failure cost tidak kita kelola, maka akibatnya adalah terjadinya failure pada critical asset kita. Nah, di sini yang saya contohkan yaitu spesifik mengenai topik kita, baik dia terjadi berupa sub-alignment maupun misalignment yang mengakibatkan performance decrease atau performance yang menurun. Nah, pada topik kali ini, Mr. Sven akan menjelaskan mengenai apa itu precision laser sub-alignment. Kemudian, mengapa kita perlu memonitor atau mengelola kondisi misalignment tersebut. Dan kemudian nanti Mr. Sven juga menjelaskan atau mendemokan bagaimana cara kita melakukan alignment yang presisi dan apa benefitnya. Kita melakukan tidak sekedar alignment biasa, namun alignment yang presisi. Nah, nanti ada kaitannya dengan failure effect di sini ya, terkait dengan unit de-rating, kemudian performance yang menurun, seperti itu. Nah, dalam hal pengelolaan aset, kita selalu berangkat seperti tampilan yang ada di software ini, berangkat dari life cycle strategi, di mana software ini merupakan software yang di-develop sendiri oleh kami, PT Tiara Webinar Pratama, yang kami beri nama dengan BOLEN. Nah, BOLEN itu merupakan singkatan dari Baseline for Overall Life Cycle Management. Nah, nanti Bapak Ibu yang memang tertarik untuk berdiskusi lebih lanjut, kita bisa meluangkan waktu untuk berdiskusi mengenai software dan program yang ada di dalamnya. Nah, nanti Bapak Ibu bisa melihat failure cost apa yang perlu kita kelola atau kita monitor pada critical asset tertentu. Kemudian task kategori apa yang melekat pada failure cost tersebut, apakah PDM, apakah PM. Dalam hal ini kalau kita lihat contoh tadi pada vertical pump terkait dengan failure cost alignment, ada yang berupa tasnya merupakan PDM atau kita melakukan monitoring vibration. Kemudian ada juga yang memang task kategorinya masuk ke PM atau preventive maintenance berupa melakukan realignment. Nah, dalam hal ini kita bisa melakukan precision laser alignment yang teknologinya dimiliki oleh isi laser. Oke. Nah, itu sedikit pengantar dari saya untuk pembukaan webinar siang hari ini. Selanjutnya Mr. Sven akan menjelaskan lebih lanjut. Oke, Mr. Sven, it's your time, please.
Thank you so much, Mr. 𝐒𝐤𝐞𝐢𝐬𝐜𝐡𝐞𝐫. Yeah, again, hello and welcome from my side. It's a pleasure to join and to present here together with company PT Tiara. My name is Sven and I'm with 𝐒𝐯. I'm going to share the screen with you. I'd like to share a couple of information basics about laser alignment in regards of industrial machines. So our topic today is precision laser shaft alignment. Increase machine lifespan and reduce maintenance costs. And there are many possibilities in regards of making the machines more reliable, reducing costs by precisely align machines or install machines. Very briefly about myself. I'm living and working from Singapore. I'm here more than 12 years now. I'm responsible in the company 𝐒𝐯 for the Asia Pacific region. So I'm the one that supports distributor in the countries in Asia Pacific, like PT Tiara, who is our distributor in Indonesia. Bit about myself, I'm vibration analyst, category 3, ISO certified reliability practitioner, category 2, also authorized instructor and invalidator, and certified as a reliability leader by the AMP. So I'm basically coming from the service angle, having experience almost 30 years in this kind of industrial activity. The content of today's presentation is machine installation, reliabilities, responsibilities, doing the right things in the right order, maximize the asset value. We talk a little bit about flatness, levelness, issues related to the machines that come through dynamic forces and soft foot, then about precision shaft alignment. So very basic, of course, reducing machine energy consumption and affecting the sustainability. So improving the carbon footprint. And then we have a small live demonstration followed by some question and answers if you may have. Precision machine installation and alignment supports long-lasting and reliable machine operation. The way we install our rotating machinery will be the way how they are performing. So we can influence the equipment's energy consumption, and with that, we can affect its sustainability. The first thing that comes to mind hearing about machine alignment is shaft alignment, and it is very correct. But it is essential for achieving reliable and long-lasting operation to do things in the right way from the start. And this refers to the installation of the machines. So the machine installation has a direct impact and will determine the operation condition, the performance, and the life cycle cost. The rotating machinery does perform as good as it is installed. Spending good money on new equipment but installing it wrong or by unexperienced installer will lead to potentially downtime, to unnecessary expenses. Monitoring the machine in its operation allows an earlier identification of potentially or possible failure. And it is something very essential. We will learn that in one of the next slides. But it is also a good idea that we should avoid those kind of problems in the machine at the very first place. So avoiding the root causes or minimize the root causes a machine can suffer from in the very first place. And that refers to the installation of the machine. So our general expectation of certain assets of the equipment is in reliable operation. We expect our rotating equipment to deliver its intended purpose or service without failure. We expect a high performance so that the equipment is performing as it is designed. And we expect a long operating lifetime. So if our equipment was initially designed for operating duration 20 or 30 years, then that's what we want to achieve, potentially more. But in many cases, that's not happen, and it relates to potentially stresses in the machine, and causes for those stresses are related to installation and operation. So we try to avoid those as best as possible. Something that comes a little bit out of condition monitoring concept and reliability corner, just for us here to recap. So the most of us know those kind of graphs. Here we see a study conducted by Nolan and Heap many years ago about a pattern all industrial assets can fail. And quite often the first thinking is that the reasons of assets to fail is age related, but it is actually only true for 11% across all kind of machines worldwide. So 89% of the machines, the very majority, is actually failing through random occurring problems. So that's, for example, the initial breakdown, completely random occurred 14%, or related to the infant mortality, that especially after installation and going into the operation, or right after an overhaul, the machine has a high risk, a tendency to fail. So the majority of the machine failure that occurs are completely random. And this refers a little bit to the maintenance strategy that you may apply. So if you do that based on certain schedules, so-called scheduled maintenance, they are all based on some expectation that the machine will fail in a certain time interval. To prevent this, you are maintaining the machine before this interval is due. But this whole thing does not work if we have machines with 89% who are just failing randomly. So that's not really possible to predict them based on some mathematic matrices or equation. And that's where we find place into a classical condition monitoring concept. To apply monitoring technology on the machine to assess its condition, in the best case, maybe once every hour, every second for very high critical equipment, or once a month, once per week. That's depend on the equipment's criticality. You also need to think about our own responsibilities. Communication, and this is something, of course, that refers again to the installation of the machine. It is a must to assure a proper communication among the design, the engineering, the installation teams. We know there are constant challenges to keep the installation work to be on time within certain specifications. The teams must have the constant communication to be able to solve any difficulties or changes that may apply. In the real world, not everything fits as the drawings showing. So I think many of us can have here an insight, have experiences, right? Second here on the list is procedures. So installation procedures must be created accordingly to the design specification, and every member of this team must be familiar with them. So depending on which industry, the procedures will differ from each other. It is not the same thing to perform an installation in a nuclear power plant compared to a pharmaceutical industry. So there are many procedures in place, safety first always, how to install when, what, and what kind of time interval is required to do a certain job. But there should be always a reference to which specific standards all of those guidelines belonging. They need to be on site, and it needs to be clear that the installation, for example, is taking place accordingly to some API. So recommended practices for machine design, that is the API 686, are perfect foundation where we could start with. So there are many guidelines that exist to lean on or to apply. The last point here is integrity, and that's important. That applies to all of us. It is so easy to take here and there some shortcuts. So the integrity is an important part of the installation phase, of course, and it starts with safety. Everyone who participates in the installation must undergo some safety training. Specific trainings must be performed, such as working in heights, confined spaces, fire protection, and chemical handling. Breaking those safety rules would put the project behind schedule, of course brings a danger of injuries, and it is very important that they are once in place, and second, that they are followed. So the installation of rotating equipment must follow certain orders. These procedures are designed to start always from the machine base. So the foundations are the cornerstone of the entire installation of the machine. They are designed to hold the rotating machine and transfer, dissipate stresses, dynamic forces produced by pulsation and machine processes itself. Therefore, special attention must be paid to the foundation. They must be flat, they must be coplanar and leveled. If we skip the order of the installation procedures, we will not be able later to complete further steps to achieve reliable operation with our rotating equipment. So, of course, you can try to align machines and correct the installation, but it is very difficult to compensate mistakes or wrong installation that have been made in the first place. So that's what we say, do the right things in the right order. Finally, all the work must be properly documented during the process created by digital reports to be able to review, to compare, to adhere values, reference data, and to further improve in the future from them, so that we can track back what could be possibly go wrong, and that we're learning out of the consequences something to do that in the next instant better. So all of those things are important, and those references will help us in the future. So we depend on those kind of results and documentations that we need to create in the first place. The installation on site, so machine installation. Some of the manufacturers of rotating equipment are doing individual testing, and they are certifying their machines before they are leaving their facility. So that's a classical factory acceptance testing, the FAT. But that does not necessarily mean that the whole system will be integrated together and work properly on site in your plant, in your facility. In that scenario, it is like you buy a new car without that this car ever have been tested. Get it, drive it, and find out for yourself how it works. That sounds, at least for me, safe and reliable. So site acceptance testing is something very useful to apply. It is used to determine the functionality of the equipment at the user site before, during, or after its installation. It was engaged a few times to analyze machines where we have here operations just a few months, but operated with issues. So involved parties start to argue who has the responsibility for a certain root cause the machine is troubled with. So nobody likes to take the blame. Was it the design? Was it the manufacturer? Was it the installation on site, or potentially the transportation of the equipment between manufacturer and site? Maybe it was the contractor. So if you are finding out a problem later on the machine, it's then hard to find the responsible body of making here improvements in the future. So factory acceptance tests is something the manufacturers doing also for themselves to say, yes, we didn't do anything wrong. Our equipment is in good condition. But before you're going in operation with this equipment, nobody has control of how it was transported and how it was installed on your place. So that is covered with a site acceptance test. The site acceptance test written by clients themselves, and it is something to verify the functionality of the equipment and how it is being tested accordingly to some requirements. The most machinery is designed to work on a flat and level surface. So we all come across many machines and assets, and again, we think about shaft alignment, how to align the two potentially more machine parts of a train through the shaft components coupling to each other. But if there are issues related on the foundation those machines are standing on, then something went wrong in the first place. Every manufacturer of pumps, compressor, blowers, electrical motors, or gearboxes assumes that their equipment is going to be installed correctly. And this means on a flat, on a level surface. And they are also providing their tolerances for it. So there are standards for the installation as well. There is the ANSI standard who recommends foot flatness. So ANSI, American Norm for Standardization, for example, says a foot, excuse me, foot flatness should be less than 0.4 micron per millimeter. Excuse me, please. And the coplanity should be less than 50 micrometer per millimeter. So that standards the ANSI is referring to the foundation of machines. Those ones applied here in an example for machineries that having a standard to be considered of 400 kilowatt, which is equal 500 horsepower. On the other hand, besides the American Norm of Standardization, we have the International Standardization Organization, the ISO. There are existing standards for centrifugal pumps, for petroleum, for petrochemical and natural gas industries. That is specifically the ISO 13709. You can all find this information, of course, in the internet. And it says clearly that the corresponding surface shall be the same plane within 150 micrometer per meter. Now try to imagine how much is 150 micrometer in flatness and level per meter of in distance or in area on in base. That is 0.15 millimeter per meter. So that's not something you can easily measure with ordinary tools, with a spirit level, for example. It is 0.15 millimeter per 1 meter distance. So flatness and levelness affects everything. So consequently, the machine that is placed later on this base requires actually checking of flatness, which is essential for the foundation and is again the cornerstone for every single installation, irrespective of its type. So we're having here machine or mounting pads, sole plates, frames, and tables. Everything you put on the top of those kind of bases is going to be affected by the condition of the base. When the flatness is out of tolerance, the rotating equipment is affected. You will have a soft foot, there could be a misalignment, there could be machine casing stress, pipe flange misalignment, many other causes. But I want to mention specifically one, and that is the strain on bearings. So when you asked all of the maintenance people which part of the machine fails the most, the common answer is the bearings. So the bearing is designed to rotate and using here an oil film. So we're having kind of a lubrication system, and accordingly to the Swedish bearing manufacturer SKF, a free running bearing with a proper lubrication will rotate infinity, so forever. That means the bearing damages are actually not related to its operating lifetime. It is always caused to some stresses. So we in the installation of the machine causes many of those stresses. When the bearing is squeezed, the lubrication film is forced out, and we will have here a contact-to-contact metal that appears. So excess heat is generated and your bearing is running into failure. That is quite simple. All other failures will be linked to this kind of stress. And it is often started with actually a flatless issue. Because if the base, if the foundation of a machine is not flat and leveled, you get those stress components inside of the machine and your bearings suffer from them. So levelness is another factor that affects heavily the equipment. Vertically installed bearings carried horizontal loads. And if you change their gravity point, the lubrication will move out of the raceway. But if you don't have a proper lubrication, there will be metal-to-metal contact. If you have splash lubrication in your machine, and if you have unleveled installation, you will move the oil away from its oil slinger. That will be the end of the story. So think about really what causes all of those problems that we know related to bearings. Very often it is actually the installation of the machine, its base, lubrication, or the handling of the bearing and machineries. In the assembly of the installation phase, the rotating equipment is being installed. Only that. Then it is handed over to the pre-commissioning and commissioning teams where the equipment is going to be tested. The commissioners will run and process. They will check the vibration, temperature, pressure. Here's also where dynamic measurements come into place. So dynamic measurement is an on-site laser measurement which is performed to measure and show movements of the machine when it is in operation. Terminal growth, pipe strain, nozzle load, and other dynamic forces which affect our equipment. For example, how does the pipe strain affect your asset? The pipe strain is the misalignment between the suction flange of the asset and corresponding pipe flange connection. So this misalignment makes a deformation of the body of the asset, and as a consequence we have also here stresses on the bearings, which leads into an increase of vibration and in a shorter operating time into a failure of the machine components, the bearings. The similar thing happens with terminal growth. The machine condition is where the increased temperature of an asset will change its physical condition and make it therefore grow in vertical and horizontal direction compared to its shaft center line. So basically it would misalign between cold non-operating and warm or hot operating condition. So if we know this terminal growth and we have chances to measure equal like all the other dynamic stresses, we can include this kind of change as a compensation factor or an offset into our called installation procedures, where we of course align the machines and install them in a way to apply them in perfectly installed and aligned condition to the operating stage of the machine. And that is in running machine, a machine that is warm. Soft foot is the term we often use when we talk about shaft alignment. In fact, you must always perform a soft foot check before the actual alignment work can start. It is an essential part of securing and reliable installation. Soft foot, we mean the machine is not resting evenly on all of the feet. Another expression is that you maybe heard is machine frame distortion. So here we're having the most common 4 different soft foot cases. That's parallel soft foot, sometimes also referred as a rocking. Soft foot means that not all 4 feet are on the same plane. Thinking of a wobbly table in a restaurant where you can rock it back and forth. The second one is a bent foot or outside angle soft foot. That's also a common type of soft foot that occurs when the foot's bottom is at an angle relative to the base. If this is the case, the laser system will show a high soft foot reading at 3 or all 4 feet. And the soft foot with the highest reading will show a tapered air gap from the corner where we have here the angled surface towards the frame. Number 3 is the squishy soft foot, sometimes also known as the spring foot. So that's where we can see here with the feeler gauge that we will not really find and detect any gap underneath the foot. Instead, the problem is actually usually in the space in between the foot and the base. So that is filled with potentially too many shims. So we not recommend not more than 3 to 4 shims in a pack to put under each of the machine feet. Otherwise, you will have this kind of squishy foot. The last induced soft foot introduced soft foot is caused by an external force that affects the machine frame. And this can be quite hard to detect, hard to find. So the laser system, which have the opportunity to measure all of the soft foot condition, will here indicate more than one soft foot, usually on the same side or the same end of the machine. The feeler gauge will not find a gap. So there are those traditional methods with feeling gauges, etc., and they are not very sufficient across all variants of soft foots, but the laser alignment system can recognize them. Now moving ahead into the shaft alignment, so not longer installation, we are now at the alignment of the machine. Rotating machine, in short words, is a construction with a movement and a driving unit. To get a movement working, there are bearings and there's a lubricant of some kind. The thickness of the lubrication point, the gap between the surfaces inside of the bearing, is very thin. It's around 3 to 7 micron at the narrow point. Now, if the lubrication is not working, we will have here a shorter availability of this bearing of the whole machine. So imagine really also from misalignment how much and how quickly this 3 or 7 micrometer is actually here achieved. So a small angle misalignment forces now your bearing to create heat, like on the right-hand side graphic, we will have metal-to-metal contact. As a consequence, the bearing is wearing out over time. And this will, of course, lead to a potential machine damage. The machine needs to be taken out, needs to be repaired, and it's no longer available for its operation. What is actually a machine? A machine power transmission. Precise aligned, the shaft's rotational center line are collinear at the point of the power transfer when machines are in operating conditions. So that is the classical statement of precise aligned. We are referring to the shafts of the machine parts who are collinear at the point of power transfer, so at the coupling, when the machine is under operating conditions. The savings, so reaching to this precision considered alignment stage, can occur from precision alignment, are often overlooked. While energy represents hundreds to thousands of dollars of operating expenses, a significant portion of those costs are purely waste. Misaligned machines cost us valuable energy dollars. So precision alignment of machine shafts have proven to cut energy costs as much as 10%. Moreover, correctable misalignment conditions are also shorten the service life of the machine, so increasing machine failure. It causes work stoppages and plant shutdowns, and therefore it reduces also the product quality. The bottom line is misalignment is expensive and it is unnecessary. Precision alignment of coupled machines reduces the mean time between failures and dramatically reduces energy consumption. A precision laser alignment at assets in our plants can save thousands of dollars over the life of a single machine. But what is shaft misalignment? Here we see one of two, the angular misalignment. So that's when the center of the two axes is not parallel to each other. Then we talk about an angular misalignment. The second is the offset misalignment. And this is when we have here a center line. They are not aligned to each other of two axes who are not concentric, but they are parallel. So classical parallel, or also called offset misalignment. In practice, the most what you can find on the assets and machines are a combination of both of them together. Now, precision shaft alignment and tolerances. So the question may come, what means actually precision alignment? Who defines what is precise and what not? So how good does the machine alignment needs to be? Precision shaft alignment refers to the excellent range of given tolerances. So while there are a number of factors to consider, the key issue when it comes to the relationship between misalignment and damage can be done to the machine is the machine speed. If the speed is greater, the damage will be greater as a consequence. So the guidelines, the tolerances and norms that we apply, referring all to some kind of relationship between an allowable gap or misalignment per certain speed of the assets. So increased availability comes as a consequence. of excellent range alignment condition. So we see that here in the graph, the green area, while the orange are often also referred to yellow, acceptable, and red means alignment is necessary. So this is the area where we are hurting the machines, where we are damaging the machines. The norms we are referring here to is either easy laser tolerance. So we have it inbuilt in all of our equipment, but you can also use the American norm for standardization, so the ANSI, specifically the S2.75. Here we see on the graphic in part of a guideline, a tolerance that is published in a book, in kind of an alignment handbook. Many people considering it as the Bible of the alignment, by John Petrowski. The easy laser tolerance or the ANSI tolerance guideline are pretty similar to them. So here we're setting our current speed that we have applied to our machine, like 3000 RPM. That is our vertical. And we find at the top the cross point between acceptable and alignment necessarily, which means 1.2 micron per millimeter. So everything greater is really requiring in alignment, but even the acceptable range does not mean it is precise aligned. Then we would need to be better than the 0.8. Only smaller than 0.8 micron per millimeter are per this tolerance table considered to be precise. But laser technology today has advanced so much that you can do it even better than 0.8. And why not? So align it in a way as best as possible, but you should be able to achieve it to be in the range to consider here as excellent. Precision shaft alignment is one of the keys to achieve high reliability in rotating machines. If you increase the load on a bearing by just 25%, the lifetime of this bearing is halved. If you double the load, only 1/8 of the designed lifetime of this bearing is left. So it's exponential relationship between stress and lifetime of the bearing. Align the 300 RPM machine to an angular gap of smaller than 0.05 millimeter per 100 millimeter. That is the diameter of the coupling flange. The machine life will be increased. That is out of question. But you cannot get even close to that degree with a straight edge alignment, and probably not with a dial gauge indicator either. So while it is technically possible to achieve that with a dial indicator, most people, experienced people, are likely not to achieve this because the dial is not that accurate. There are other issues related. So you need consequently a precision alignment technology, and that's today laser technology. Instruments like this, that's the Easy Laser XT770, allow a user to perform laser alignment with high measurement precision and in very convenient usability. So the whole system is app-based. It can operate on the default display unit, but it can be also communicate with the same app, and that is an Android or iOS-based app. So the app is possible to download for anybody from the App Store. It calls XT Alignment App from Easy Laser. It's completely for free. Download it, install it as an app on your either iOS or Android-based instrument. And then you have everything you need from the software side. Of course, you would require to have hardware, so the measurement units, the laser and receiver. But there's a good redundancy, and the customer can decide on their own taste what kind of display unit they want to use. There is no licensing, there is no password or something to key in. It's for all the application the same app, and it's completely for free. I'd like to show you a short video about the Generation XT, like the XT770, in system made by 𝐒𝐳𝐸. Let's maybe listen in.
Everybody has their passion. Mine, reliable machinery installation.
Reliability, consistency, sustainability. Trending words on everybody's lips, and words that describe 𝐒𝐳𝐸 very well. A reliable installation of your machinery is vital, since faulty installations will cost a lot of money. Precision shaft alignment is one of the cornerstones and the starting point for reliable machinery installation. Generation XT covers it all, from base flatness to dynamic measurements. If consistency means having a long-term perspective on things, that is very true about 𝐒𝐳𝐸 and Generation XT. The products of Generation XT from 𝐒𝐳𝐸 are designed to last. They are water and dust proof, as well as sturdy and rugged. They also come with a built-in adaptability. Our systems are easy to upgrade and expand, now or in the future. In combination with our commitment to support and service, this means sustainability for the investment made and for the environment. We support the user through the entire product lifecycle. Sustainable, consistent, and reliable.
So, what's your passion?
Generation XT from 𝐒𝐳𝐸.
So this is the latest now since a couple of years available laser alignment, Generation XT by 𝐒𝐳𝐸. It has many advantages, and I said one of them is the app functionality, that we got rid completely of any kind of license, any kind of passwords. So everybody can always upload or download, of course, the latest app from the App Store and just use it as it is. So there's not something like a hassle to key in passwords and things like this. Go a little bit further to show a little bit more about the individual parts of the system. So XT is a generation, and we have one example, say it's the XT770. But there are more variants. There's 440, 550, and XT660. And all of them are cross-compatible without that you need to, key in here any passwords. You can add belt alignment tools to the same XT app, even vibration, flatness measurement, level measurement. And I will show you a couple of things that later here after the presentation. But here now another video with a bit more details about the components of such measurement systems.
Generation XT. Know your machine from every angle. Generation XT from 𝐒𝐳𝐸 keeps growing. The system now covers measurement and alignment needs from basic level to advanced stages. We proudly introduce the new XT770, the latest addition to Generation XT. It's the go-to system for advanced measurement and alignment of rotating machinery. Easily operated through the same app as all other units in the XT series, the XT770 allows you to align horizontally and vertically or flange-mounted machines, but you can do a lot more.
Among the advanced functions, let's take a look at some of the highlights. With Easy Trend, you can keep track of machine movement over time. A machine train puts extra demands on you. The XT770 allows you to easily and quickly accomplish even the most complex of jobs. You can perform continuous sweep and multi-point measurements. Once the results are in, the machinery is ready for adjustment. And with the 360 Live feature, the 2-axis XT770 lets you align both vertically and horizontally from any position, allowing you to know your machine from every angle. Use the XT app on 𝐒𝐳 award-winning XT11 or on the device of your choice. Why spend time learning different systems? One is enough. Generation XT is based on one app that lets you work on any display unit with any XT unit. With the XT770, the 𝐒𝐳 XT range now covers all measurement and alignment needs when it comes to rotating machinery, from basic to advanced level. Generation XT. Know your machine from every angle.
All right, so I will show you them live very soon in a couple of minutes after the presentation, and would like to just mention here, after installation and shaft alignment, there are other functionalities also combined in the same XT app, and they are worth to consider. So what you have to do with belt-driven machines. So we're having here sheave and pulley alignment. That's an XT190, so a tool that includes an inbuilt detector. It is actually the only one worldwide. All the other that you can find on the market refer to a printed scale on the receiver that still the technician, the engineer needs to read by themselves. So here you find an alignment technology applied for sheaves or pulleys, where we have really, besides the laser, also a receiver who measures with an accuracy of 1/1000th of a micron. Sorry, 10,000th of a micron, 1/100th. And this allows you to align those sheaves with an evidence that is based on the measurement instrument and not on the technician. So you can create in the same way like the other XT family members in provided report that shows then to your customer, supervisor, or other persons that yes, you have aligned properly and precise the equipment using the inbuilt electronics. So that makes our life easier. A very short video about this.
Presenting the XT190, an easy-to-use belt transmission alignment tool. Easily operated through the same app as all other XT units from 𝐒𝐳, the XT190 is a reliable solution, giving great results and returning your investment in no time. When aligning belt drives with the XT190, you will extend the life cycles of sheaves and pulleys, sprockets, belts, bearings, and seals. This is accomplished through a reduction in wear and waste, along with low power consumption, all contributing to environmental sustainability. In short, good alignment will prolong the life of your belts and pulleys, reduce noise and vibration, and minimize costly downtime. One operator is enough to accurately perform alignments on wide, single, or multi-belt machines. Using the app on a separate display unit, you can remain where you are adjusting the machine. With visual targets, the accuracy may vary depending on who does the job. But with the digital readout, anyone can accurately align within preset tolerances and rely on the result. The XT190 comes with an integrated OLED display. But you can just as well choose to follow the adjustment values live with 3D graphics through the XT app on your mobile device or on the XT11 tablet. The app allows you to set tolerances, save data, and create a PDF report. The digital readout and documentation options are unique to 𝐒𝐳. The XT190 is attached magnetically to any ferrous sheave or pulley, regardless of size, in a matter of seconds. The laser transmitter goes on one of the sheaves and the detector on the other. The transmitter generates a laser plane parallel to the reference sheave. The detector reads the position in relation to the laser plane and provides a live digital display of offset, angle, and twist. Using the app, you also get shimming values. This makes the alignment of the adjustable machine very simple. All in all, the XT190 by 𝐒𝐳 is an easy-to-use and reliable digital belt alignment tool. Operated through the same app as all other XT units, the XT190 provides accurate and efficient results in real time with multiple readout options documented with a graphical report. 𝐒𝐳. Straightforward by all measures.
All right, and here one last slide in reference to alignment technology. So we have seen shaft alignment, we have seen belt alignment. Now we have here precision alignment related to the foundation, to the base, to a frame, etc. So related to the installation. Such systems offer today many more functions and operations for measurements. So measuring the machine software is included by default, of course. The same applies to monitoring the machine through dynamic stresses at the machine with special brackets. So here we're having terminal growth. We have soft foot. There's the special bracket that allows you to use the same measurement laser and detector measurement units, not installed on the shaft, installed on the body of the machine, to measure dynamic stresses. While you are starting up the machine into the operating stage, you basically monitor permanent and live the X and Y deviation, so the parallelity and the angularity of the machine parts to each other. And this is used then as an offset to be applied to the initial alignment on a machine that has a cold condition, so that when it is operating or warm up to operation level, it is aligned accordingly to the tolerance and reference. Then the same detector, the same system, again, that's the XT770, would allow you to use, for example, in emitter and laser, like here on the bottom, which has the rotatable head, to apply flatness and level measurements. So even perpendicularities, so square angles can be identified and measured. So there are really a lot of possibilities in regards of the installation, and all of them are covered with the same and one app. It's just connecting the needed measurement hardware and go ahead with it. The last one here that we see is the XT290, and small tool, very precise digital precision level. I will show it to you once here in the video, but also later on the live video feed. So that's the last video before we're going ahead. I will demonstrate you this very briefly. The last slides we have here are about machine operating costs. So we said at the beginning, precise alignment helps us to save actually money. So what are the machine operating costs? Let's think for a moment about the life cycle costs of a pump, similar machines. About 70% of the fully lifetime operation is alone the power consumption. So yes, we have energy, we have purchase, operating, maintenance, downtime, lost production, and other cost factors. And the really big portion, 70%, represents everything the machine is taking power over its lifetime, and that's huge. Now, the power consumption is something we can influence by precise aligning the machine. The significant power savings can be made through accurate alignment. During a survey in a plant, the findings have showed that more than 90% of all the rotating machineries outside are outside of the offset alignment tolerances. The tolerances that we have shown earlier, and 90% in a couple of surveys actually in various plants, showing that the majority of all operating machines are not inside of the tolerance. So that means precision alignment reduces energy consumption of all of them who are not precise aligned. It's clearly, if you remove stress alone from the coupling, from the bearing, the whole machine, the requirement of rotating the machine through the motor and all of its components is less. Therefore, it takes less power. So consequently, reducing stress, which means aligning the machine precisely, is reducing costs. The energy consumption has the greatest potential to reduce costs among all live operating machines related factors. Precise machine alignment eliminates reactional forces and reduces the energy consumption by up to 10%. So here we see a chart that represents in misalignment offset in millimeter. So starting at 1.4, 1.8, quite severe misalignment in offset, and compare it with 0.2, potentially 0.0, so something in the hundredths and thousandths. And this can reduce power consumption by 10%. An example, in 75 kilowatt pump operating 8 hours per day, 300 days per year. I'm calculating here in mixed power consumption across the world. That is in Sweden, in the US, in Germany, in Singapore. Energy has different prices, but the average is around 0.067 euro per kilowatt. So this times 75, we have here 5 euro per hour, times 8 hours a day, times 300 days per year, means that the energy consumption here is 12,000 euro every year. The 1 millimeter misalignment that was found was then reduced through precise alignment to 0.2 millimeter only. And this, in the initial power consumption, can save up to 660 euro per year. Now, is this number a lot or not? Compared to 12,000, well, it is quite a bit. But 0.2 is not the most precise, so you can even do that better. And now consider that not only on one machine. Take 10 machines, 50 or 100 machines just in your facility. How much money saving potential actually precise alignment could mean? And it's not the only saving potential we have, but by far the most severe. How about bearings and mechanical seals? The misalignment puts unnecessarily load and forces on bearings. In the industry today, less than 10% of all of the bearings in machines reached their designed lifetime. So they fail earlier as designed. And this means there are root causes for it. So misalignment contributes here with more than 50% to those causes of machine failure. Removing the root cause misalignment and having a precise aligned condition also as a consequence extends life of bearing, of seal, and therefore reduces costs over time. So here we see a bit animated through a graphic the difference between an offset misalignment of 1 millimeter versus 0.2 millimeter, vertical versus horizontal. And we can even reduce it further down, so less than 0.2 millimeter. Also, the mechanical seal life can be extended by many, many months. So think about the stress components in a machine, in a bearing, just through misalignment. Machines like pumps, etc., with a speed of 3000 RPM and more, we have here seen tests and surveys on the market, like in a chemical plant, and all of them have shown only 8% of all the tested machines were at an acceptable tolerance. So bringing them into the applied tolerance allows us to save a lot of costs. Just to recap, up to 10% of power consumption can be saved through precise laser shaft alignment. Bearings and seal repairs can be reduced. The repair of pumps have declined as a consequence in all of those plans and assets that have been tested inside of the survey. The machine lifetime can be utilized fully and beyond. Remember what is actually our expectation, that the machine potentially runs without repairing, theoretically, over 20 and 30 years, just maintaining it properly. To summarize the benefits of precision machine installation and alignment: increased lifetime from the operating machines, reduce costs of spare parts, bearings, and seals, reduce maintenance, labor costs, and improve planning, reducing costs on brackets, on documentation issues, improve plant operation and reliability, increase plant availability, reduce power consumption of the single assets in your whole plant. One important factor, improve plant operating safety. That's something we always and we all are interested. And a contribution to a cleaner environment. So we're having on our website from 𝐒𝐯 Laser many articles with surveys and tests that have been made. You can find them in the blog. So here are in this document just a few of those links, a shortcut directly like laser alignment justification. So an instrument that helps companies to do precise laser-based alignment, and what are the savings afterwards. Savings for sheave and pulley-driven machines. Proper alignment will reduce your carbon footprint. And other hidden opportunities to create savings. We reached now the end of the presentation. So we are using now quickly in a live demonstration, which I'm doing here behind me at my home in 𝐒𝐸𝐶T 770 shaft laser alignment on a demonstration rig. I apply and I show you the tolerances and how does it work, how quickly it can be done to align a machine precisely. Second, I will do the same also here with applied tolerances on a small rig to do sheath alignment. And then very briefly, digital level with the XT290. After that, we have some question and answer. For the moment, I'm pausing this presentation, minimize the screen, and share with you a camera footage that seems to be frozen. There we are. So on the right-hand side, there's an installed camera that points on a table behind me. I'm starting right now in tablet, an iPad on which I'm running the XT alignment app that allows me to mirror it to the computer screen so that you can see exactly what I'm doing besides of the camera. Just give me a second. I'm activating the mirroring. Okay, here we are. So here I'm having the alignment app, and I think the best is that I'm showing first the default display. So this is the standard display unit, which contains, of course, the application, the XT alignment functionality. Just putting this quick a bit to the side. In the meantime, I'm starting up the measurement units. So I'm doing basically now the communication with the installed measurement units on the app of the tablet. That's just for the purpose that I can air the screen directly to the computer so you can see them. So whenever I'm clicking on any of the menus, you can see that on the shared screen. The same application, of course, runs here on the default display unit. I just in the moment for favor to share this on the screen, work with this iPad. It doesn't matter, it's the same app that can run on any smartphone, tablet, or like those default display units. So that's the default system. We have packages that include by default the so-called XT11 and packages without, so that the customer can decide, well, I'm having a smartphone, I'm having a tablet, I'm using this instead. So here everything is the same, touchscreen based, just the camera with the light maybe it's not working properly. I have here a very small demonstration rig where I say on the left-hand side, I'm having my stationary machine. So that's then typically the part of the machine combination that is my reference, which is non-movable. And towards this kind of reference, I'm adjusting the position of the machine right-hand side of myself. So on here, the right measurement unit, I'm considering this as the movable machine. So I'm doing the correction on the right machine only in vertical direction and in horizontal direction. So we're having here two measurement units, which having, yes, on each side an emitting laser and a receiver. So we're having basically two laser beams. that go here inside of this detector. It is one of the largest on the market by 20 by 20 millimeter in the square shape. It allows us to measure with 1 micron over a distance of up to 20 meters. So as larger the detector inside of the measurement unit, as further away I can place those two to each other, up to 20 meters. Now, of course, here I'm having maybe 10, 15, 20 centimeter. Where would I need 20 meters? Well, think of it, the same measurement units you can use to measure flatness. You can use them to measure straightness. But also think about machines like a cooling tower, where you have in gear inside sitting on the top of the fan inside of the cooling tower that connects to a long spacer shaft to the motor that is basically outside. So 20 meters I have seen applications 10, 15, etc. And that's then an easy possibility. Extruder, for example, is also something with a long distance. One very nice feature that I like particular the most is that we see the inclination on the measurement instrument directly on it. So I know always in which angle the measurement unit is placed. And it can be very helpful adjusting and put it on the brackets. The brackets, we have seen it in the video, are classical V brackets put here on the shaft, tightened, and we're having our 2 posts where the measurement unit is sit on and secured through the holding screws. Now I open the detector, dust cap or protection on both sides to have them in laser beam. At the moment it's in sleep mode. So smart intelligence inside puts the instrument in the moment into sleep, since I do not have a communication to a display measurement unit. So now I'm using my Apple device, tablet, where I'm running the XT alignment app on. So you see that directly on the screen. I go first into the machine or file manager. So here I'm having all kind of saved results, but I can also save templates. So I created a template that contains already the measurements of this machine between left, right, where are the feeds of the machine, etc. So I open just this template and start to create a new measurement. So here we have now a combination of motor and pump. Of course, that refers now here to this demonstration. I can look at this and adjust the graphic just through navigating on the touch screen, as I'm basically standing in front of the machine. That helps me with the orientation. You can change the machine just hitting the plus. Say, what is the name? What kind of configuration the machine is in real life? Is it a compressor? If it is a gearbox? If it's a generatic machine, and so on. So there are many, many graphically templates here in to make it best possible representing the machine we are aligning. I stick to the pump, go back. I check maybe distances. I can change the locked foot. Here I'm having, if I know a certain temperature value, so terminal growth, that we can apply here a certain offset. That would not make sense at the stationary machine, more on the movable machine. So let's switch to the right-hand side machine. That is our motor. Same configuration that I can change here. I go further and say, here are my temperature growth, for example, my offset between hot and cold that you can key in. You can, of course, measure and then transfer it into this reading right away. And the last point is referring, besides all the dimension, the coupling itself. So here, related coupling and shaft, I'm having the measurements or data related to the speed. The speed is important, you remember, when we're activating a tolerance. I have a coupling diameter, coupling type. Let's look into tolerance. In the moment activated here, easy laser tolerance, I switch to the one from the ANSI. So there are the references related to the speed. The machine is set up with 1480 RPM, but you can create also your own tolerance, maybe from the manufacturer received experiences that you have. So create your own tolerance, it's also fine if this is a requirement. So I'm using the ANSI. And now the template, the machine setup is created and I'm starting to communicate. The measurement units have an auto off just to save the battery capacity in the meantime. So I need to turn them on first to establish a communication. I'm clicking on the left-hand side and there are my measurement units. They are in the moment, because they will fall asleep, not shown as available. So let me just go back. Let me turn on and off to make here a new readout. It could be that they are already connected to my default unit, so it's better to turn this off, since those ones can only communicate and be paired with one instrument. So it could be very likely that historically they were still connected to my default display unit, so I just turned it off and put it on site. Now I likely need to refresh them. Sorry for the interruption. Just turn it on and off. Okay. Just trying to refresh so that I can establish the communication that was reserved with the other display unit. So I'm open the same template again. And in the moment they do still not appear. Let me just close the app completely and open it again. Sorry for the interruption. Now they are shown on the top side. Sorry, there's another window on the screen. Shown now as available. So the measurement units were still occupied and memorized the communication with the default display unit. I need to turn off all of them to refresh and have now here communication and activate them to communicate with the app that I'm running on the tablet. So here I'm now connected to them. And I see on the left-hand side the two targets, so both detector, one's on the pump, one's on the motor, left and right of the coupling, showing now the laser point in a target. So before I start to measure, I should adjust them as best as possible into the center. So we're having here wheels on the right-hand side in this one measurement unit that allows me to basically adjust the angle of the laser beam inside of the detector. So we see here thousandths of millimeter. You see, I hope there's not a lapse that the laser dot in the target is moving, but also the real data. So at the top pump, we have now 0.039 negative and 0.136. That is good enough. Now the other side for the motor, I'm going a little bit down and a bit to the side just to point it better into the center. That is good enough right now. We have here at the bottom right-hand side of the measurement display, soft foot. So I say that is actually something we should consider to do first before we are attempting to do the shaft alignment. So I see now here a slightly different graphic of the machines. Go into my readings and just follow the guide. So basically it tells me tap any foot to measure. I'm taking the top right-hand side and measure now in real, just loosen the foot. Now I'm having 0.012 and I'm tighten again. So I'm tighten a bit more strong and you see that actually my curve and absolute value is recorded. So I'm going back to the original level. So it's like recording the movement when you are measuring and loosen the one bolt or the one foot. The same on the other side. It was quite loose and just tighten it a little. So that's basically readings that we're taking here into the calculation. But in a moment, it was just to demonstrate how soft foot works. So I'm going back to the initial reading to shaft alignment. Of course, realistically, we would need to measure all 4 of these soft foot results and then doing the correction before we are proceeding to do the shaft alignment. But this is not so much about explaining the process of shaft alignment. It's more about to show how the app works, how the measurement equipment works. So we have prepared the machine, and here I can switch between different measurement modes when it comes to shaft alignment. Easy turn, it's 3 measurement points in certain positions. Any positions I like, as long there's 20-degree gap between each of those 3. Then we have a very traditional method that says measure in 9, 12, and 3 o'clock. So the guide on the display tells me move actually into the 9 o'clock position and take a reading. Then it would take 12 and 3. I can say multi-point. So take a reading anywhere you like. So multi-point means multiple readings at any position that is possible to take or you think that will be needed to collect. I'm choosing the sweep mode. Sweep mode is like a recording function which measures hundreds of readings while I'm rotating live. And that's an advantage of the xt770. So I'm starting here to go in a certain position. There's a little bit a lapse between the camera and the app. That is through the mirroring function on the screen. What I'm saying right now, start recording. So the instrument tells me, well, tap and stop suite when I'm finished. So I'm rotating now my shaft and collecting data while the shaft is rotating. So I have about 180 degree, 90 or less degree of swipe is possible. I collected now 668 measurement points, and I have here a quality assessment that says, while I'm measuring, my influence factors and everything in summary achieves a quality of 82%. I will repeat this to show you what this quality assessment is doing. I take a second reading. So new measurement, I'm start a recorder, and now I'm doing something like interruption left, right. That is, of course, not realistic. We shouldn't do that, but that's why we're having the quality parameter. So I'm doing here, playing with the backlash and doing something deliberately wrong. Now I say stop. As a consequence, my quality reading on the right-hand side in the yellow graphic that you can see is now 69%. So the first one was 80%. I take a third one. So just to verify, to find out which one is the better. A third measurement reading, start the recorder and rotate. That is then smooth in one direction only. So that achieves the best results. Stop the recorder and achieved 81%. So now I'm having 3 different readings. And I like to see what is the result of each of those readings. So I'm switching to the next screen that shows me the condition. And here I'm having the table from all 3 readings. If we quickly collect the one number 2, that was the bad one, we can see here details. Measurement errors while I have rotated. How is my rotation speed? It was quick, slow, stopped. The quality is here accessed for me as a traceability. I say actually that's not the best one out of the 3. So there's measurement readings collected in number 3 or 1 that are way better from the quality factor. And I can choose which of the 3 readings I'm now taking to do my alignment of the machine. So I actually disable number 2 because I say that was not a good measurement reading. But I can combine. I just say take 1 and 3 together. So you can measure 2 times, 5, 10 times, and can mix them together. You can basically choose which one you like to have in the average calculation and which one not. So I'm considering now an average that has 82% of quality, and the related results will be updated automatically. Now I'm looking about the condition. So we see them here in 2-dimensional. Left-hand side vertical view of the machines, on the right-hand side the horizontal machines. And we see one's parallel misalignment and second angular misalignment in both of them. Now some people like to have vertical alone, horizontal alone, both together, or in 3-dimensional. So now you see on the screen, on the left-hand side vertical, on the right-hand side horizontal of the movable machine. Since we activated tolerances, they are indicated with the related colors. So red would be very bad. Next is orange. Then we have yellow. And the best is green. So inside of these certain tolerances of few steps. And depend on my result, I'm belonging to one of those areas. And they are here indicated with colors. Now I like to do my alignment. So here on the bottom, we see the viewing options and still considered or saved as found. Switching at the top to the right-hand side to this little symbol that indicates shims. I'm now in the menu to do the alignment of the machine, so the physical correction. And here I can choose in different monitoring features, either on certain positions my measurement unit is placed, or, and that's here the, I say, considerable easiest measurement method or correction method called live 360. So I activate and now I measure live with the 2 laser on the detector, and I access parallelism and angular in the same time, no matter in which angle my protector, my measurement unit is placed into. So all what I have to do is now making the correction. I'm losing a bit the vertical screws. So you see actually live on the screen what kind of correction I'm doing in vertical or horizontal. So I'm concentrating on the one on the top right-hand side. Of course, in practice, I would need to do the vertical shimming alignment first. We're skipping this in a moment and doing the horizontal alignment. So I'm pushing now here horizontal, the machine with those adjustment screws into the right position. And you see how the numbers in real time, that's the thousands, are changing, as well the colors behind. So horizontal looks fine. Now I'm doing the vertical tightening my machine. And I achieve here very quick a reasonable alignment correction, the alignment condition. So the only thing that is left out is the top left. That's the parallelism in vertical direction. I would need to make the correction with the shimming. I, in the moment, skipped this part. So of course, it goes better than that, but the purpose in the moment is to show you how the alignment works. I'm going into the last step and say make a report. So here I can choose between multiple layouts. They are implemented in the system, how the report have to be look like, with graphics, with pictures that you can take with the camera, of course. I'm sticking to the one that we see here, right there. We see the as found condition. We see the corrected condition, all the parameter, our tolerances, and can add some notes. So I say I'm finished. I finalize this measurement reading. I can give it a name that stores the result into my system. So it's just date and time. And now I'm sharing it. I can send it out via email right away through the default display unit or through the operating system on the tablet. You can store it. You can have it as an XML file, so Excel-based or PDF file, etc. And that's it. So very quickly, we have here played through the guidance of the instrument to align shafts on a machine. Second, I take this away. Now we're running a bit out of time.
Mr. Sven?
Yes.
Maybe we can start first with some good questions here?
Of course.
Is it okay?
Yeah.
Okay.
Any question?
Yes, we have some good questions here, and I will start with the questions in the chat. And I think from Pak Agus Prianto and Pak Hasanuddin Naiborhu, I think the questions already answered ya during the demo. Mungkin kalau belum terjawab bisa di chatting lagi Pak. Saya rasa dari Pak Agus Prianto dan Pak Hasanuddin Naiborhu pertanyaannya sudah terjawab ya. And okay, the first question for you, Sven, about can our technology measure the leveling in the steam turbine?
Can this technology measure? Say it again.
The leveling in the steam turbine.
So you mean the level of the machine base or the turbine body itself?
Yeah, I think so.
I can show you the digital level, which is just a small measurement tool called XT290. That's the digital precision level. And that works for anything where you can put it on. So of course it has magnets, there are various brackets, and it measures basically with a thousandth of a millimeter the angularity of the object where you are measuring it. So if you do that across multiple measurement locations, it can be any object. Now, if you talk about that's level straightness or flatness, then we would install in reference laser that is placed potentially on a tripod outside of the machine, points across the base or the machine part, and then we're using magnets together with brackets to put the detector across the machine and collect the readings. And then we get a three-dimensional result that tells us in grid points how flat, how even the whole measurement object looks like, to know then the correct values and machining it. So there are many ways to measure that.
Yeah. Okay. And then the other questions. Questions from Pak David Haryanto. I think this is also already answered, yeah, that our technology is laser can use to align a big machine, including turbine, gearbox, compressor, and the others.
Yeah. And
yeah, another question for you, Sven. Is it the XT can use to measure in the plant with the high humidity and high temperature, like around 40 degrees of Celsius?
Yes, absolutely. So in general, the measurement unit having an IP rating of IP68, the measurement units. Then the default display has an IP rating of 67. So very reliable in regards of protection inside of very humid or hot places. So the temperature range to be used is 10 to 50 degrees Celsius, which is the ambient temperature. So the XT generation is one of the instruments with the highest IP rating that you can find on the market. And to come back to the previous point, how about aligning large machines? So large could mean in diameter on the shafts, but also distance. So the distance is in our case limited to 20 meters when we talk about shaft alignment, and that's already the highest distance you can find on the market. But distance could mean shaft alignment, but also more. we have other additional laser and detector that can measure in the same accuracy up to 100 or 200 meter. That applies for potentially flatness. So that's of course something a little bit extraordinary, and not everybody used it. But if it is required, you can just add another laser, which is over distance more consistent to achieve hundreds of meters, depend on the application. In cranes, for example, in roller parallelism alignment, for example. When we think about diameter in regards of size, there's actually no limit. Yes, the bracket has a limit in its V shape and the chain, how it's tightened, but we have special brackets, and we can also use different kind of magnet adapter or screw adapter that you can install on large diameters, for example.
Yeah, thank you, Sven. And next question, does the XT have a capability to do the reverse alignment?
What do you mean with reverse alignment?
Reverse alignment.
You're referring to dial gauge input.
Yeah, I think.
Yeah, so there are some models that exist so that you take the readings that many of you potentially know from the dial gauge results. So you can calculate them in a kind of coefficient, which can be used to be input as a requirement inside of the laser alignment instrument. So the way of measuring is different, but you can cross them with some coefficient to know how good or bad the older achieved result versus the newer one is. In general, you say dial gauge is not the same measurement principle like laser alignment, but you have a possibility to key in the related results of dial indicator alignment, reverse measurement technology in a laser instrument, yes.
Yeah, thank you, Sven. And there is a question from Muhammad Rendo. Can we perform live horizontal movement without rotate the laser to the horizontal position? Because sometimes for some equipment, it is not easy to rotate the shaft without changing the sensor position to horizontal.
So when we talk about the correction, yes, absolutely. So I demonstrated actually the alignment, that means the correction of the machine without changing the position of the shaft. That is possible with the XT770 since it uses a 2-axis PSD in both measurement units. Now, there's another consideration how to measure. And I think the question relates a little bit to machines which are not possible to rotate so easily. So we have a way that calls sweep mode or uncoupled sweep mode, that you can actually work with one shaft which is not rotatable. You keep the measurement unit on it, and the other one, which is then either be rotatable by a magnet slider, or the shaft itself is just swiping over the surface with the detector towards the laser beam, and then you change the position. So there are a couple of videos for this person who asked us questions we can share with how to do that. The technology exists. So the short answer to this question is yes, absolutely. How does a little bit work is the best way to show in a video.
Yeah, thank you, Sven. And next question about the distance, about the easy laser distance. We have two questions here, identical. The question is, easy laser can do alignment with the long shaft or coupling with 3 meters or above the 4 meters.
Yeah, absolutely. So the instruments specification in the XT series are related to the measurement unit. So we have XT 440, 660, 550, and the one that I showed you is the XT 770. So the most of them can measure up to 20 meters.
Until 20 meters. Yeah.
Yeah, and if you imagine, why do we referencing the distance to the size of the detector? So the detector inside of the measurement unit, I mentioned it's 20 by 20 millimeter. That is one of the largest. So I'm not talking only about the window that we can see from the outside. It's actually the detector behind, and we have one of the largest on the market. This means an angular misalignment is of course over distance increasing. So that means you need to have a larger surface on the detector to capture this misalignment. And we, through the large detector, 20 millimeter, can achieve 20 meter. And this is still in an accuracy of 1/1000th of a millimeter possible.
Is it also possible with the shaft with the high diameter? Or,
yes, absolutely.
is it possible? Yeah.
Yeah.
Okay. Of course, yeah. And then from Q&A, we have 2 questions from Pak Gopinaga. The first question is about the alignment checking intervals or frequency. Do you have a recommendation?
That you mean that the instrument tells us the necessary interval?
Yeah, regarding to the alignment, he asking about the frequency of the monitoring or the checking intervals of the alignment of the machine.
Yeah, there are so many influence factors in making this decision, which the instrument, of course, cannot know. So what's the criticality of the instrument? What's the operating duration over a week, over a month? How old is the machine? So those parameters are usually covered by a classical maintenance program that calculates then intervals like this and says when to measure what and how. The instrument itself can in the future very soon actually be shared in a cloud-based database where we interacting then data with those kind of maintenance tools. That means you can get a notification through a third-party program that tells you when to measure. The instrument itself does not tell us when, because it doesn't have an interface into all of the criteria that are deciding about the interval. But it is classically solved through an additional maintenance program.
Yeah, thank you. And then second question from Pak Gopinaga. You do alignment something or a machine, and after a period of time, the alignment got disturbed and not achieving same value again. By the way, what is happening?
Is this a disturbance when you are measuring or when you are correcting?
He do the alignment and already get the targeting value, and then yeah, we don't know the specific disturbing, but I think from external or something, and then the value of the alignment changes.
I'm trying to imagine what could be the cause. So in general, when we measure, it's a couple of seconds. Of course, depend on the machine. Can you rotate the shaft? It could maybe last a little longer. You're going in single measurement positions and you swipe, there are different options. Now the quality assessment allows us to see, is the measurement disturbed? So you should always try to achieve 80% average to say this is now a good measurement to have something to start with. You can easily go back into the menu anytime and re-measure, change the reference where you are aligning to. So if you are not certain that there was maybe something that influenced your measurement readings or the measurements during the correction of the machine, it's very easy and straightforward to go back into the menu, quickly remeasure and then continue. Now, while you are correcting the machine, what is the purpose of the measurement instrument? It records basically all kind of physical movements to go to the range of being precise aligned. It would not know where this movement comes from. Is it from your machine correction, or does it come from another influence factor, which is disturbance? So this differentiation is not possible to make. That is then up to the engineer to recognize and then to compensate or to remeasure.
Okay, thank you, Sven. We have two last questions here. The first one is how to anticipate to align a machine with the not good soft foot. Yeah.
Well, we really need to make a correction on the soft foot. So define what means not good, good, acceptable. So if we are having a bad soft foot, then the alignment, the shaft alignment would not be very good. So we depend very much on the condition of the machine is placed evenly on all of their feet. What's the character of the soft foot? Depend on how much you tighten, which foot you tighten when, in which order. The machine will twist in all kind of direction. And this makes it almost impossible to achieve in good alignment, because every time you make a correction, the machine will be placed in a different origin position. So first we need to solve the soft foot issue to start with a good reference, to do then the correction of the machine's alignments towards each other. This is essential.
Yeah. And last question, for cardan shaft alignment using this XT, do we need to dismantle the shaft, or can we perform the alignment without dismantle the shaft or U-joint?
Yeah, okay. So we have in measurement technology together with brackets that are installed on the machine coupling flange. This requires to take off the joint or the cardan itself. So that's called in-situ cardan alignment. We from our side prefer to recommend in alignment of the machines without the stresses of the cardan shaft itself, to access the single shafts of both machines independent from each other without the cardan, which also leads to specified larger distances. So there's a solution on this market that says, yes, you can align machines, so that's not easy laser, within cardan connectivity to each other without taking this cardan out. But it's also limited in offset. So the distance, vertical or horizontal, of the length of the cardan is limited. So it makes it maybe only for certain application possible to apply, or the others are still required to take out the cardan shaft. So long story, in our case, it is not possible. We prefer to take out the cardan shaft to remove the stresses of the machine by twisting and rotating the shaft and measure them independent with a kind of offset bracket.
Yeah. Thank you, Sven, and that's all our questions. I think you have two more demonstration, right?
I can,
And
if you allow me quickly, just a few minutes, if you like to have it.
Yeah, of course, please.
Then I'm sharing the screen again. So I'm still using the same app on the tablet. What I'm having here is the once emitting device. So the laser for the 𝐒𝐲190, so a tool to align pulleys and sheaths. I'm putting the laser on the stationary one, so the one that I'm not correcting, not moving. And I turn on the laser. Maybe that's those magnets we don't use. So we are working here with a line laser, as you can see here in the video camera picture. And I'm representing through those line lasers basically the angle, the height, or the depth, depend on where we are placing, of course, this pulley, the pulley itself. On the right-hand side, I have here the detector. The detector is here behind this window. I'm turning it on. So the detector, like in also the shaft alignment instrument, measures very accurate over distance. It is a rechargeable battery inside, and we will see on the display itself what is my reading. Of course, I need to put it against the laser beam. So now I could use this completely without app, with any digital instrument, just by reading the information on the screen on the display of the detector. I'm using the app. So the app is free to download. You can have it on a phone or on a tablet. And I say communicate through in Bluetooth communication with this receiver to do belt alignment or sheath alignment. So here we're having the machine. You can coordinate, sorry for this window. You can change the view, depend on how you would like to have it in regards of stationary or movable machine. You can play with the dimension in different viewing angles. I go to the right-hand side machines of my movable machine, and here I'm having, besides sheath diameter, the width, etc., also the tolerances. So I'm applying here a tolerance of 0.2. Actually, I don't have measurement results, dimensions. I'm going quickly back into my main menu, open the file manager, and here I'm having already a template for belt alignment. And I'm just using this one because it has already some inputs. So open selected. I just need to unlock. So I create a copy. Now I adjust here. I have there my dimension 250. I have dimension here in the sheath width, in the diameter that is representative for this little demo rig. Looking into the tolerances and change it to 0.2 degree. And now I'm going ahead to collect data. So I'm going into my measurement menu, choosing the detector. So at the moment I'm communicating basically with this device via Bluetooth. And I have my first readings. So we see once vertical and second horizontal V in H, the angle. And the sheath in the middle is basically the parallelism. So we're having here 0.36 written in the middle. And At the bottom, we see the correction values of the sheaves, and we see here indicated through arrows in which direction the machine or the part of the machine has to be corrected to be aligned and aligned accordingly to the tolerance. I basically need to lower, so I'm doing first the parallelism a little bit. So I'm doing now live the correction. Okay, so I have now achieved 0.04 in the parallelism. And now I'm doing the angle. So once vertical and second horizontal. So we are measuring permanent live, everything transmitted directly to the app. And there are my corrections. So you can see that either in 3D, you can see that in 2-dimensional. Now changing this angle changes now again my parallelism. So I'm now up at 0.93. Changing and tweaking here a little bit. And I achieved quickly the tolerance values, everything indicated as green. Sorry, this was the right one. I would need to lower now the sheaf again. So the one that I corrected earlier, but it was the angle actually that was here responsible. So I just skipped this part. So it's very easy to follow the guideline of the app. It doesn't really require training how to handle the instrument to align perfectly here with 0.04 degree in angle and hundredths of a millimeter. Switching to protocol, save my measurement reading, and can send it, can print it, can transfer it to USB stick or other media. All right, the last part is this digital precision level. I'm going out of this menu. So this is basically a measurement device to access level. I'm turning it on. Unfortunately, the display doesn't work with the camera. So that's the refresh rate of the camera. Doesn't see us really the display on the instrument, but hey, we have the app. So we want to measure that with the app anyway. So I'm going into values, which is kind of a recorder. I'm having on the left-hand side now connected the serial number of the instrument. So that is the �XT290. Connected Bluetooth. Here are now my readings. So it's very sensitive. As you see, it's a thousandth of a millimeter as well. And it measures both angles. So parallel alongside the shape of the measurement unit as well in the second like X and Y angle. So I'm just putting here some shims beneath. We have here -8, now 0.2. So to bring it quickly in level. So I know now, hey, my table is not in level. So the table where this digital precision level instrument is placed on. So it works in ±100 degrees. There are many features. You can connect to the app 4 of those at the same time. So that can be helpful when you measure circular shapes, long distance related shapes. You'll be using the same instrument to do measurements in regards of parallelism on the vertical axis, to bring roller, for example, into the vertically parallel same axis. And then there's a way to do that in horizontal axis as well. So here, measurement readings, I have here graph functions. Of course, I didn't take any measurements. Whenever I hit the button manually, I take a reading. On the right-hand side on the screen, it will appear. So I can take as many readings I like, depend of course on the measurement position. I can start a recorder. So instead of doing it by hand manually, I just program a recorder and say, measure every second in a duration of 1 minute, maybe 2 hours or longer, and start my recorder. So now it shoots in stored result every second. I'm just changing something that we see the differences. And I say stop on this point. So I have here now a long table of almost 20 measurement readings already. There's my result in graphical ways, in table format. That's a nice tool for certain application. Depend on usually things like level and parallelism you look like. I like it a lot, very accurate, but also very easy to use together with the app. All right, this concludes the quick, maybe not so quick, it took a lot of time, live demonstration.
Yeah, thank you, Sven.
Thank you.
That's a great presentation and demonstration.
Thank you.
To our customers. And this time already 4:20 p.m. here. And all the questions already answered by us. And I think this is the end of our webinar today. Thank you again, Sven.
Mr. 𝐒𝐤𝐞𝐢𝐬𝐜, thank you.
Yes.
Thank you so much for having me. Thank you for the opportunity to demonstrate a couple of things to your customer. I just want to appreciate your organization and making this happen so quick. And also maybe say that for those ones of you who are interested later to see those instruments in real, please contact the persons in charge from PT Tiara to potentially arrange a visit, another demonstration. Maybe also in the next following month, there could be an opportunity to meet in person. So I hope I will have the opportunity then soon to also visit Indonesia and maybe together with Mr. 𝐒𝐤𝐞𝐢𝐬𝐜 to see some of you. Looking forward. Thank you so much.
Yeah, looking forward. Sven, thank you so much. Oke, Bapak Ibu, demikian tadi webinar bersama Sven Fleischer dari 𝐒𝐤𝐿aser. Kalau masih ada pertanyaan atau beberapa hal yang mau didiskusikan, silakan. Dan sampai ketemu pada webinar kami berikutnya. Terima kasih.